All right, for our first question, it is a midpoint question. And so we need to find the midpoint of -7 and -5. So we have -7, we have -5. So right there in between them should be -6. So that's going to be our midpoint. Okay, looking at number 2, this is going to be where, if you remember those Pythagorean triples, that's going to be very useful. We have a 3, 4, 5 right triangle. And then you can also multiply that by any value, and that would generate more. You also have a 5, 12, 13. That also comes up. And sometimes 7, 24, 25 shows up. But mainly these two. So if you remember that, notice you have 5 and you have 3. So that missing side has to be 4. Now, if you don't remember that, you do have your Pythagorean Theorem that you can use. And so C is always pointed out by the right angle. So we have 3 squared plus missing side squared equals hypotenuse squared. So B squared equals 16, or sorry, my goodness, I'm already subtracting that. B squared equals, 16, sorry guys. So B is going to be 4. So there's your missing side. Okay, moving on to number 3. We have the Fahrenheit temperature. F can be approximated by doubling the Celsius. So where are we going to talk about doubling the Celsius? Well, that's not going to be yet. So right off, it's either going to be here or here, because that would double the Celsius. And then what else are we going to do? We're going to add 32. So this one would actually be adding 64. So we're going to have answer choice C for that one. Okay, number 4, Malcolm has 3 striped ties and 4 solid color ties hanging in the closet together. In his haste to get to his appointment, he randomly grabs one of the 7 ties. What is the probability that the tie is going to be striped? So here we know we have a total of 7 ties, so that's how many he has to choose from. And he only has 3 striped ties, so our answer for this one should be 3/7. Okay, for our next question, we have the daily totals of lunch customers served at a cafe last Monday through Saturday, and we have all those numbers and what is the average number of customers served. So we just need to find our average. So we need to take 256 plus 189 plus 204 plus 179 plus 166 and 218. And we're going to take every one of those and we need to divide by how many we have. So 1, 2, 3, 4, 5, 6. All right, and that should give us answer choice D. Okay, moving on to number 8. Here we have lines that are parallel, and I need to know which of the following must be congruent to angle X. So we have a nice property from geometry that tells us if we have 2 parallel lines cut by a transversal, that our alternate interior angles, they are congruent. So it looks like we need to have answer choice, it looks like it might be answer choice K for that one. Sorry, not J. It would be K. My gracious. All right, so again, alternate interior. By the same idea, let's list a couple more that would be congruent. It looks like 2, that angle there, is probably going to be congruent out here to 3, so that would be another set of congruent angles. Okay, moving on to 7. All right, so a package of ballpoint pens. They are on sale at $1.50, or they're being sold for $1.50, and they go on sale for 20% off. So you have a couple of options. one option, you could take $1.50 and you're going to subtract 0.2 times $1.50. Or if you're doing 20% off, then you're actually only paying 80% of the price. So either one you want to do that, it looks like you're going to get answer choice D. When a triangle is isosceles, its parts are given special names, which are shown below for triangle ABC, where AB is congruent to CB, so that means their legs are congruent. If two isosceles triangles are similar, which of the following must be equal? And so if it's an isosceles triangle, you know that you have two angles that are going to be, or two base angles that are going to be congruent. So it looks like here, then if those are the same, then this angle in turn would also have to be the same. So that tells me that it looks like answer choice K. We have the measures of their vertex angles. They're all going to have to be congruent. Okay, moving on to the next. Okay, so for number 9, we see that this person has a cash settlement, and after she gave her lawyer 25%, she had $12,000 left. So the remaining amount that she has is 75%. So 0.75 of what gave me $12,000. So we're going to solve this equation, and we're going to have 12,000 divided by 0.75, and it looks like that's going to be answer choice A. All right, and number 10, Carlotta has 2 more CDs than Mario. Well, Carlotta and Mario, and let's see, Carlotta has 2 more CDs than Mario, so if Mario had 1, Carlotta would have 2. Now, let's see, she buys 3 CDs from Mario, so Mario had to have at least 3 CDs, which means Carlotta had to have 5, because again, she still has 2 more. So if she buys all 3 of these from Mario, then those are going to come over here. So Carlotta has 8 more CDs than Mario. All right, moving on to number 11. What is the value whenever x is 6? Now, these problems are missed because students mess up on their order of operation. So you have to go ahead and do the inside first. And the absolute value of -3 is 3. Okay. And so this one is going to want us to FOIL out all of this. So when we're going to multiply through, we're going to take 2x and we multiply it to everything that we have. So 2x cubed plus 2xy. And then on the inside, minus x squared y. And then minus y squared. And so let's find which answer choice that's going to match up with. And it looks like it's going to be answer choice K. Okay, number 13, we're going to take this -3 and we need to distribute it to each part. So we're going to have 5 minus 3x plus 12. And combining our like terms, we have -3x plus 17. So that's going to give us answer choice A. Number 14, whenever you raise an exponent to an exponent here, you need to multiply. So we're going to have x raised to the 60th. So answer choice F. And with this one, this looks like it's a very intimidating problem. However, we can go through and notice that this decimal repeats after 1, 2, 3, 4, 5, after the 5th digit there. So what we're going to do to find the 311th digit, we're going to take 311, if my pen would write, and in that 311, we are going to divide it by the number of digits that we have here that repeat, which is 5. And so we're going to old school this. We know that's going to be 30 and 11. So we're going to have 2. And we look at the remainder because this remainder tells us which digit we're at. And so with this, we see that we're at the first digit, and that first digit is a 5. So that's going to be answer choice B. All right, and for number 16, the area of a square is 6 square inches. What is the perimeter? Well, if we know the area formula, we're going to set that equal to 36. So our side length is 6, and so the perimeter is 4 times S. So that's going to be 4 times 6, which is 24. So 16 should be answer choice K. Number 17 wants to know the sum of the solutions of the equation. So when we're going to do that, there's an old formula that we could use, and that sum is equal to negative b over a, and the a and b come from the ax squared plus bx plus c. And so for here, the sum of these roots are going to be 2 over 1, but we need the opposite of that, so it's going to be negative 2, which is answer choice C. The other option, you could factor and then add those together, but this is a super quick way. All right, which of the following expressions is not a polynomial factor for x to the 4th minus 4? Now what that means is, if I plug in this, if I take right here and I sub that in, I'm going to get a 0. That's what it's talking about here. So what we could do with these is we can multiply this out. We could substitute in and multiply out, but that's quite a bit of work there. Now if we set x to the 4th minus 4 equal to 0, we would have x to the 4th equals 4. And then we would be looking at the 4th root of 4, so that's probably not going to work either. So it looks like our only option here is probably going to be to factor. So we have to remember with just 2 terms and even exponent, this is the difference of squares. So I know that's the same thing as x squared squared minus 2 squared. And so when I factor this, I have x squared minus 2 times x squared plus 2. And since we're looking for factors, we can set this equal to 0. Well, we see that x squared minus 2 and plus 2, those are factors, so we're going to eliminate those two. Now, this part right here, that is prime, so we need to continue on with this one, though. So we're going to have x squared minus 2 equal to 0. And notice this is a weird one that we could factor. We can factor that into x plus the square root of 2 times x minus the square root of 2. And notice that's going to give us those answer choices. So all that's left is answer choice K. Okay, moving on. When x equals 1/2, what is the value of what we're given? We could do a quick way with this since we only have one denominator. You can divide this up and say, well, that's 4x over x minus 3 over x. Well, those are going to cancel. So I know it's 4 minus, and now we can go ahead and sub in our 1/2. And so that's going to give us 4 minus 3 divided by 1/2. Keep in mind that's really the same thing as this, which is our keep, change, and flip. So we're going to have 4 minus 6, which is negative 2. Okay, number 20. Right, we know that distance, my pen would work, distance equals rate times time. And we are, let's see, we need to go 90 kilometers. And we need to know how many minutes that would take, and we're traveling at a rate of 120 kilometers per hour times our time. So we need to divide. So we're going to have 90 kilometers over 120 kilometers per hour. That's going to give us our time. And so this is going to give us 90. So that's really, if we reduce this down, we're going to have 3/4 of an hour. But that 3/4, that's in hours, but I needed to know how many minutes. So we need to take 3/4 and we need to multiply that by 60, and that's going to give us 45 minutes. So answer choice H. Right, we have an isosceles trapezoid, so we know these side lengths are the same. These bases are parallel to each other. And we have our formula. We don't know what the height is, but we know the sum of our bases, 12 and 6, that's going to give us 18. So whatever our area is 9 times the height. Well, if we go ahead and we drop our height here, we know this is the longest side. So from that, then this side length's options would be a 1, 2, 3, or a 4. So let's go through here and see which answer choice would have to be it. 1 isn't going to work, 2 is not going to work, 3 might could work, and 4 might could work. So those are our two possibilities. So we've eliminated here, here, and here. So we know that side has to either be a 3 or a 4. And chances are it's probably going to be a 4. And let's see how we might know that. Well, if we chop off this other end, so we know these side lengths are going to be equal to each other. And 12, well, there's 6, so 6 is left, so they're going to be 3 and 3. So, yeah, it has to be a 4. But we had a good idea of how to narrow that down for sure. All right, so for 22, for a certain quadratic equation, we have two solutions. Which of the following could be the factors? So this is really working the problem backwards. So let's take x equals 3/5. So let's work our equation backwards. That means I would have moved the 5x back over, and then I would subtract my 3 back over. So 5x minus 3 equals 0. That would have been one of them. So, wow, look, that automatically eliminated all of them but f. So that was pretty easy. All right, and then for our next one, number 23, all the sides of a rhombus are the same length. If one diagonal is 10 and the other is 24, how long are the side lengths? Well, okay, let's see. So we've got a diagonal, and one of these is going to be 24. And we know that these side lengths are equal to each other. Okay, so we could go ahead and generate, let's go ahead and generate the other diagonal. And these are perpendicular bisectors of each other, by the way. So here, this is 24. Let's go ahead and just label them the other way. So I know this is going to be 12. This side over here is going to be 12. And the other one was 10, so I know this is 5 and 5. I bet that we have a 5, 12, 13 setup here. So how many inches long is one side of the rhombus? I would imagine it's going to be 13. So 23 is answer choice C. All right, number 24. We have a rectangular room, and we are told that, a pen going, that the length is 2 feet longer than it is wide. So if this is the width, then the length is W plus 2. And we're told that the area is 120. So let's think about what's going on here. W plus 2 is 120. And they just want to know how long is the room. Well, these two things multiplied together has to give me 120. So let's look at the factors of 120. So let's see, we could do 3 times 40, but that's not real useful. What about 10 times 12? That would fit this scenario for sure. And so that would tell me that the length would have to be 12. Okay, moving on to 25. We need to know the slope of the line. So our slope formula, y2 minus y1 over x2 minus x1. And here's our numbers. So the slope for this one, we're going to say 4 minus negative 7 over 5 minus 2. And so it looks like we're going to get 11/3. So that's answer choice D. Number 26, we are asked for the center of the circle. And this is already in standard form for us. So we have to flip signs, but our center is sitting right there. So our center is going to be positive 2, comma, negative 2. So that's answer choice J. Right, now we're asked for the domain, would be the set of the domain. So domain is how far to the left, all the way over to how far to the right. And so it looks like our domain is probably going to be answer choice C. All right, so we have the point -1, 3, and we have the point 2, 7. And we need to know what is the midpoint of the line segment there. So let's see, we would add these two, find the distance between these two. So we're going to have 2 minus 1. And so that's going to give us 1, and divide that by 2. So that's going to give us a half. Now I don't see any other x coordinate that's a half. So it's going to be F. Now keep in mind, I'll give you the formula. It's going to be the sum of the x coordinates and then divided by 2. And then the sum of the y coordinates divided by 2. Let's see, number 29. So this person is traveling, and I want to know what is her average speed for the parts of the day where she was traveling from one place to another. So from here, she was traveling from 0 to 2, and she traveled a total distance of 110. So we know for distance, or for the hours, we've got 2 hours was 110. And then this represents where she stopped, and then she started traveling again. And it looks like, again, it was an interval from 2 to 6, so another 2 hours and 220 here. So it looks like, again, she's staying pretty constant. She's traveling, again, at the same amount here from 8 to 10, so again, 2. So let's see, from here to here, she's traveling 2 each time, and then at 110 divided by 2, that's going to be her rate or her average speed, so that's going to give us 55. Number 30, which of the following statements must be true? Well, if you're dividing with like bases, you would subtract your exponents, and it's top exponent minus the bottom exponent that had to give you your answer here of x cubed. So that's going to be answer choice F. Hey, the slope of the line is a super short way to get that slope. If you have your 5x minus your 4y equals 3. If you'll draw your fraction line here and change your sign, so your slope is going to be -5 over -4, which is positive 5/4. So that's going to be answer choice D. For 32, which of the following is the least common denominator in the expression? So it's just like variables. Whenever it's written like this, you are going to pick out each number, and you're going to grab the one with the highest exponent in each one. So I see a 13 squared. So 13 squared has to be part of my least common denominator. I see 17s, but 17 squared is the largest, so that means that one's gone, and it also means K is gone. So my answer choice is J. For our next one, if we're multiplying all of these fractions together, we do need to keep in mind we can do a lot of canceling here. Anything on top with anything on bottom, and notice there's a pattern here. And so all of those things look like they are canceling out. So I have a 1 times 2 on top and a 9 times 10 on bottom. And of course that 2 is going to cancel there. So we have 1 over 45 left. Number 34 is a great application of the Pythagorean Theorem. We want to know the distance of this dotted line here. So we have the square root of 100 squared plus 150 squared, and that's going to give us answer choice K. 35, this is saying that if we were to sketch any other ellipse, how many places would you have to intersect? And looks like you would always have to intersect in 4 places. All right, for 36, Environmental Club selects 3 officers, and we have 20 members, and no member can hold more than 1 club. So if we start looking at all the different possible results, well, we're electing for 3 spots. So you have 20 choices for the first, 19 for the second, and finally 18 for the final. Number 37, all the points 1, 1, 5, 2. All right, so the coordinates and plane of 2 vertices of a triangle ABC, and it has a right angle. What could be the 3rd point? So we could go through and plot some of these. We have the point 2, -3. So 2, -3 would be somewhere down here. Or we could do 3 and 1.5. So 3 and then 1.5. That's kind of strange there. This part C is going to be 3.5 and -0.5. So 3.5, 3.5, and -0.5. Hey, that's looking like that might be a little bit better. Right, and what about 4, -2? So 4, this was at 3.5, 4, -2. All right, well, let's see, that's looking even better. And then 4, 6, so over 4 and then up 6, so that's going to be way up here. So which one of those, if we have a right angle, looks like it's probably going to generate for us a vertex? So looking at it, it looks like probably the one furthest up here, because we've got to have that right angle. So it looks like that's probably going to be our best choice. So that's going to be answer choice E. All right, 38. What value of n will satisfy this equation? A couple of ways we could do this. One, of course, you could plug in, or we could do our algebra, which would give us 0.1 n plus, and if I multiply this by 0.1, that's going to give me 135. That's going to be equal to n. And then we could get our n's together on one side. So subtract that over, that's going to give me 0.9n. And if I divide that, we're going to get answer choice J. Number 39. So we're over in all of this first part. This is talking about being in the first quadrant. And we have this equation, and we want to know, well, what does sine have to be? So if we talk about over in this first quadrant from 0 to 90 degrees, and let's solve our equation for sine. So we have 2 sine squared x minus 1 equals 0. So sine squared x is going to be 1/2. And if I take the square root of both sides, then sine x It's going to be plus or minus, but since we're stuck in the first quadrant, we know it's going to be positive square root of 1 over the square root of 2, which is really root 2 over 2, and that's going to be answer choice C. Number 40, a circular fountain with a diameter of 20 meters is to be placed entirely within a rectangular plaza, 40 by 60. Ooh, okay. So we have a rectangle, we have 40 by 60, and the bricks will be laid on the entire plaza around the fountain, but not under it, making it accessible to pedestrians. What is the approximate area in square meters of the plaza? Alright, so what we need to do, we have this circular fountain sitting on the inside. So we know the area of the bricks on the outside, that area is going to be 60 times 40. And then the area of the fountain, that's going to be pi times r squared. And our r value is going to be 10, so it's going to be 10 squared. So we need to divide these two and see what we get. Not divide, I mean subtract, silly me. So if we subtract these two areas, it looks like we should get about answer choice H. Number 41. So looks like we have equation of a line, and we're talking about parallel. So let's see, a polyline goes through this point and is parallel to this. Well, I know my slope, if we're parallel, is going to be 3. And if we go ahead and write out our equation, we have our point slope, y minus y1, equals our slope times x minus x1. And very quickly from this, we can see that y equals 3x plus 2. And so that's going to be answer choice E. Number 43, we have cosine of an angle, and we need to go ahead and finish out this triangle here. So we have this side length here, and we know this was 2, and this side is over here is 2. And so with those, we are going to see that this side length is 2 root 2, and cosine is of an angle is going to be adjacent over hypotenuse, and so we're going to have 2 over 2 root 2, and those 2's will cancel, and then you need to rationalize this, and so you should end up with root 2 over 2, which is answer choice G. Number 43 is kind of a tricky question, I guess. It's weird, but the only way really to get the largest amount is subtract those, because you would then end up with minus a negative, which would be plus a positive. Our next problem, we need to find the value of x that will make this a true statement, and it's going to lie between which of these numbers. So we have x over 2 plus 1 equals 3 over 4. And so x over 2, we're going to subtract 1 over. So we're really subtracting 4 over 4. So we're going to have negative 1/4. So x equals negative 1/2. And so that looks like that answer is going to fall between negative 1 and 0. 45, we have the absolute value of this set of numbers has to be greater than or equal to 5. So that means one case is already here for us. It's greater than or equal to 5. So z is greater than or equal to 3. So we need to find that. It's going to be here and here. So we can drop this, and we can drop this one. And we also have another side, so I don't think it's going to still be that. Now the other case that we have to investigate is going to be 2z minus 1 is going to be less than or equal to negative 5. And so solving that, we are going to see that we end up with answer choice B. Number 46. these are working with trig identities, and it's a little bit easier for these if you separate them and say tangent theta divided by sine theta. And sine theta, that's about as simple as we can go, but tangent we know is sine theta over cosine theta divided by sine theta. And we are dividing, I'm going to put that over 1, and then this is where we would keep and change and flip. So I'm going to change division to multiplication, and I'm going to flip this second one. So that's going to be 1 over sine theta. And notice those do cancel. And so I'm left with the answer choice G. Number 47. So what are the real values of A that make this inequality true? So let's do a little bit of algebra on this. Since A is a GCF in the numerator, I'm going to factor it out. So I have A times B minus C. And then in the denominator, I have a 2 that's common, so I'm going to factor that out and have B minus C. And notice what's happening here. Those B minus C's should cancel each other out. So A over 2 is less than 0. So A should be all of these negative numbers. So that's going to be answer choice E. And number 48, we have the volume of a right cylinder. And notice they've given us the volume formula. And they want us to find the new volume if R is doubled and H is halved. So let's go ahead and take our volume formula and let's substitute in what we know. Well, pi is going to stay pi, but for R we are going to double that, and that squares from the formula, and we are going to take half of the height. So we're going to have pi times 4r squared times 1/2 h. And notice if we simplify this, our volume is going to be pi times 2r squared times h. And so notice that we're going to get 2 times the original amount. We have 2 times pi r squared h instead of just pi r squared h. So our correct answer is J. On 49, I have no idea how to say that child's name. So he rode a bicycle mostly uphill to his friend Brad. The trip to Brad's house took T minutes, so I know T. Returning home, which was mostly downhill, this was able to travel at an average speed of twice of that of the trip to Brad's. And then you want to know which expression indicates the total number of minutes this child rode a bicycle. So if it took 10 minutes to get to Brad, and plus, because I need the total of minutes, if it took him, his average speed was twice as fast, so that it's really going to take him half of the time. So that's going to be 1t plus 1.5 t, or plus a half t, 1.5 t, which is 3/2 t, which is answer choice B. Number 50, we have a wheel that is 50 inches in diameter, and it is rolling along a line without slipping. How many inches does the wheel roll along the path of 25 revolutions? So this one's interesting. You need to deal with the circumference of the circle, which is pi times the diameter. So the circumference for this particular wheel is going to be 29 pi. And that circle, or that wheel, is going to make 25 revolutions. So that's going to be 25 times 29 pi. And that's going to give us answer choice K. All right, moving on to 51. With 51, we are told that we have a square inscribed in a circle. And what is the perpendicular distance from the center of the circle to the side of the square? So somewhere in here to the side of the square, we need that perpendicular distance. Well, we can't really call that our radius, but we do have a point from up here to the center that would be the radius. And actually, this is a square, so these two sides are equal. And so we're talking about a 45, 45, 90 right triangle. And if we know the hypotenuse is r, then all of these sides are going to be r over the square root of 2. It's an old geometry formula. So if we want to know this side length here, well, it's r over square root of 2. And do remember that you have to rationalize. So multiply top and bottom by root 2. So we have r root 2 all over 2. So that's going to be answer choice B. All right, number 52 is what I would call a huge waste of time. You can work out all of this if you wanted to. 52 problems like that I would skip and then come back to if I had time. But read through it, and again, there they can have any values, but it's up to you. I wouldn't waste my time on that one. Okay, so for our next problem, notice that we have a circle, and then we're going to cut a circle out of that circle, and we need that the remaining amount is going to be equal to the area that was cut out. So we know that the radius of the large circle is going to be 2 inches. So I know from the center of the circle, roughly the center, all the way out to here, I know that is 2 inches. So I know the area of the big circle is going to be pi times our radius squared. So it's going to be pi times 2 squared. Now what I want to happen is when I take this whole area, which is going to end up being 4 pi, and I subtract from that the area that was removed, which is going to be pi r squared, the remaining amount is equal to the same amount that was removed. So we have a weird equation set up, and we're going to solve this for r. Now I'm going to bring down 4 pi equals, I'm going to add this over, those are like terms. So I have 2 pi r squared. And then from here I'm going to divide both sides by 2 pi. And we're going to have r squared equals 2. So the radius here, if r squared equals 2, then r would have to be the square root of 2. So that is answer choice C. Number 54, strange looking problem. And we are really asked to find the height of this triangle is what it's asking us. And let's see, we know 15 degrees, and we're looking for this side here, this height. And if the whole part of our base is 12, we know that the height is a perpendicular bisector, so these side lengths would be 6 and 6. So we really just need one of these two triangles to talk about it. So we're looking for this missing side, and that missing side related to the known angle is going to be adjacent. And this side over here is going to be opposite. So the only trig function that deals with opposite and adjacent, that is going to be tangent. So we're going to say tangent from the angle that we're looking at. It's going to be equal to opposite over adjacent, which is what we're looking for. And an old algebra trick, if you want to solve for x in this proportion, just swap places with x and whatever's on the other side. So I have x equals 6 over tangent of 15 degrees, and that's going to be answer choice F. Number 55, we have one hot air balloon that is 10 kilometers east and 30 kilometers north of an airport tower. So let's draw that out. We have 10 kilometers this direction, and we have 2 kilometers up. Okay, and then from that same airport tower, we have 2 kilometers west, another air balloon that is 2 kilometers west, and 5 kilometers south. And they want to know what is what is the distance between these two hot air balloons. So I need this distance from here to here. And it's very tempting to say, okay, 5 squared plus 2 squared and the square root of that. But notice that the distance of this side is more than 2. We don't exactly know where we're crossing between that 10 and that 2. So we can't do that. But we can take that same idea, and if we extend this side down and this side across, then we can make us a triangle. And so I know this portion here is the same as this over here, so that's going to be 5 kilometers. And I know the length of this side is going to be 2 plus 10, so this is 12 kilometers. So here, notice the total side length on this side is going to be 7. Now we can use our Pythagorean theorem and find it. So we're going to have the square root. Well, we can do 12 squared plus 7 squared equals that missing side squared, and take the square root of both sides, and we will get answer choice C. Okay, let's do 56. 56 is strange. We do need to keep in mind with this, our rule is if we have the nth root of 2 raised to the p power, that is really 2 raised to the p over n. And they want this to always be a positive integer. So looking at this with those rules, for this to be a positive integer, then this has to divide nice and neat. So that means this would also have to be a positive integer. So that's going to be answer choice F. 57, again, very strange. And at first I think it's trying to mislead you to think that this one of these two would have to be negative, but this greater than 0 kind of disproves that. But one thing is true is we are decreasing in value. So if we're multiplying and we're decreasing in value, then that means we need a fraction. So that's something we have to be careful about. We need some kind of nice small fraction. Well, E and D are both negative, and we know this is greater than 0, so that's not going to be a good idea there. So here, and even though we could say, well, both of them could be negative, still, we're going to run into problems with the way the inequalities are set up if we try that. Okay, so here in C, this isn't really going to generate a value small enough. The only one here left that's going to generate a value small enough is going to be answer choice A. Number 58, we need to go ahead and sketch off. We're going to have a rectangle, and we know that rectangle is a 12 by 18. So that almost looks like a square, but y'all use your imaginations. That's a 12 by 18. And so they want to put in a pool that has to be at least 2 meters from the fence all the way around. So I've got to come in 2 meters all the way around. So 2 meters on each side. I really am subtracting 4, so that's going to give me 8 by 14. So really, I have this circular area here that's an 8 by 14, and really our maximum value here, it wants to know blah, 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 how many meters long should the radius of the pool be. So the radius of the pool is going to be from here to here, and so it's not going to make any sense for us to be looking at half of 14, because that's definitely not going to be the radius of the pool. Half of 8, definitely. That's going to generate the radius of our pool. So that's going to be answer choice F. 3 distinct lines, all contained in a plane, separate plane, blah, blah, blah. All right, so what are the possible numbers of distinct regions of the plane that separate by any 3 such lines? So let's draw us a plane. And I would start by the diagonals. So there's one distinct line. Here's another distinct line, but we've got to have 3. So if I throw in a third line, we've got 1, 2, 3, 4, 5, 6 distinct regions. So let's see, that one doesn't have 6. That one doesn't have 6. So let's draw another plane and see if we can come up with a different number. And I would be that smart aleck kid. I would just draw 3 lines. 1, 2, 3. Okay, well, how many regions would we have here? 1, 2, 3, and 4. So now I'm looking for 4 and 6. So now we have 4 and 6 and 4 and 6 here. So you can either take a great guess on this, or we can keep trying, either one. The final answer choice here is going to be E, because here we could probably tilt a line a different direction and we're going to end up with 7 different regions. And finally, number 60, we have this equation and it's talking about our distance. We are on the real number line. X is to A is 7 units. How far apart would be our 2 solutions? So first we have to realize that there are 2 solutions here. If we say the absolute value of x minus a is 7, then x minus a has to be 7 itself, because the absolute value of it was 7. Or, oops, I don't need that, x minus a is equal to negative 7. And the reason why is because, well, what's the absolute value of negative 7? It's 7. So x minus a had to be there. So how far apart is 7 and negative 7? Well, they're 14 units apart. That's answer choice K.